Assalamualaikum and good morning. Okay, now we want to continue our week 2 on system of linear equations and matrices. As you can see, last week we already cover, I think, 3 system of linear equations, matrix determinants and matrix inverse. Today we're gonna go through elementary row operations, Gauss elimination, Gauss-Jordan, and matrix factorization. Elementary row operation. Elementary row operations can be used to transform matrix into its row echelon form that we learned last week. Okay, and if we denote row 1 by R1, means that if you can see in the matrix, this is row 1, R1, row 2, R2, row 3, R3, and so on. A is a scalar. The 3 elementary row operation are as follows. We have 3, right? First, we can swap 2 rows. Equations denoted R1, R2. This would swap row 1 and row 2. Means that if this one I say R1, R2, means that row 1 is swapped with row 2. Okay? And the second one, multiply by a row, by a non-zero scalar, means what? A is non-zero. So let's say AR1, this will multiply row 1 by A, means that let's say A is 2R1. So 2 multiplied by row 1. And 3 add a multiple of row to another row, denoted R1 plus AR2. This would add A, let's say 2R2 to row 1 and replace the previous row 1. Means that R1 plus 2R2 and it will replace to row 1. Okay, we will see in the next example. This example shows us a linear equation system. Okay, and this is the augmented form of the linear system. We already learned this last week. This example shows swap between row 1 and row 3. This here shows that a swap has happened between row 1 and row 3. So this is row 1, this is row 3, and there have been a swap here, so that we can see here the new row 1 is actually row 3 before, and now row 3 is row 1 before. This example shows a multiplication of row 1 with A equal to -3. So -3 R1. This is A R1, so A is -3, -3 R1. As you can see, this is our R1, and this statement here, this here shows that R1 will become -3 R1. So here multiply by -3. Okay, 1 become -3, -3, -4, -3, 1, -3, -4, -3, 2, -3, -1. So -3, 1 is 3, -3, -4 is 12, -3, 2, -6, -3, -1, 3. Okay, so if you can see here, R1 becomes -3 R1, so everything will be multiplied by -3 for row 1 and replace row 1. This example show multiplication of row 1 with A, which is -3, so it becomes -3r1, and add the multiple row to another row, row 2. So we want to change row 2 here. Based on these statements, row 2, the new row 2 will become, the new row 2 will be based from row 2 minus 3r1. So first we need to calculate the 3r1. Alright, so this is the 3r1, -3, -4, -2, -3, -1. This is 3r1. This is row 2. Row 2 is 3, here, 3, 2, 2, -1, -1, 4, 4. So this will be the new answer for row 2. This replace the first one, row 2, this one, to this one, this one, to this one, this one, to this one, because here, row 2 is based from row 2 minus 3r1. So this is row 2 minus 3r1 equals to what? And this answer will be replaced back to r2. So this is the equation. The notation means to take row 2 and subtract 3 times row 1 from it to produce the new augmented matrix. This is what we have done in this example. Okay, Gaussian eliminations. How to do Gaussian elimination? Assume that a system of linear equation has one solution. Carry the augmented matrix of the system to row echelon form. Row echelon form is what we have learned in previous week. Assign the non-leading variables as parameters and solve the leading variables using back substitution. Every matrix can be carried to row echelon form by a sequence of elementary row operations. This is what we have learned before. By interchanging two rows, we can interchange, right? Swap. Multiplying a row by a non-zero scalar means that you have A R1. So this is multiplying a row. Adding a multiple of one row to another row. So we can add multiple of one row into another row, just like we did from the previous example. Okay, first example, solve the linear equations. So they give us these linear equations. How to solve this? First thing we do, find augmented matrix for the system. So we already learned this many times before. Now we want to reduce the augmented matrix by elementary row operations to row echelon forms. Okay, as we know, the row echelon forms, this is the leading entry, must be on the right of the previous row, and then this one must be 0, the column underneath the leading entry, and then this doesn't matter. Okay, this can be any number, they also can be any number, but this one is the leading and this one is the leading entry. Okay, now row 1 will be exchanged, swap with row 3. Okay, when they swap row 1 to row 3, the row 3 previously here will be at the top and row 1 will be here. Okay, so we will have 1 as a starting point. Okay, the next step, according to our row echelon form, this one should be 0. So how to change this to 0? Okay, we do this by applying these equations. Okay, let's say m to 1. M21 refer to this place. Okay, so this is 1 1 2 1 3 1. Okay, for M21 the equation they use is negative A21 divided by A11. So negative 21 is 3, this position is 3, this position is 1 1 is 1, so when divided it's negative 3, so this is negative 3. M31 refer to here number 2, A31 divided by A11, 2 divided by 1, but they're negative here, so it will be negative 2. So the M31 will be negative 2, sorry, negative 2. Negative 2. Okay, so based from this, the R2 and the new R3, this new R2 and new R3 will be changed by R2 plus negative 3R1. So this is the equation, this is R2, this is R1, this is our negative 3. So this is the new R2 and this is R3, negative 2, and this is R1, and this will change our new R3. So as you can see, both of the first 2 1 and 3 1 here become 0 as our row echelon form. When you do the calculation here, you will get the first 2 1 and 3 1 as 0. Then we can simplify this row 2 by dividing it with 7. So from 14 it become 2, 7 will become negative 1, and this one 7 will become 1. It will be simplified. According to our row echelon forms, zero, zero, zero. This one already finished. We already got 0 here for both of it. Only one left. This one should be 0, which is 9. So how to change this 9 to 0? So we calculate a new M32, M row 32, which is 9 here. A32, which is 9, divided by A22. A22, which is this one here, 2. So we get negative 9 over 2 because we have negative here. So the new row 3 will be R3 plus negative 9 over 2 R2. So this is our R3, this is our negative 9 over 2, this is our R2. And when you do this equation for all of R3, you will get a new R3. You can see here, 0 will be 0, and 9 plus negative 9 over 2 multiply by 2, so you will get 0 here, and 3.2 and 9 over 2, which is 3.2 9 over 2. Then we can see our matrix now has a row echelon form, whereby here we have our leading entry, and under the leading entry is 0. Okay, so we can change this to the equations. 1 here will become just x1, negative 4 x2, 2 x3, 0 we have nothing here, so 2 x2 minus x3, and this one we don't have x1 and x2, we have x3, so equals to 9/2. So we can calculate the answer. Once we got the equation like this, we can make a back substitution to get all the answers. For x3, these portions go here, so we will get x is 3. So for this one, x is 3, x is 3. How to find x2? This one go here, divide by 2. So this is the equation here, and you get x2 is 2. So you put x2 is 2. How to get x1? So this one and this one, both of them move here. So you will get this equation, and the answer for x1 is 1. Now we will go through another example of system linear equation. They ask us to solve this equation. We have x4 here. Before this we only have x3, now we have x4. The first step is of course to change the system to augmented matrix. Okay, now we want to change m to 1 here to m row 2 1 here to 0, right? So what we need to do is a to 1 divided by a11 1 will become -1. So this is -1. We want to change this row 2 by row 2 plus m to 1, which is -1 multiplied by r1. So you will get r2 plus -1 r1, and this one we change our new r2. So 4 will be 0 0 1 1 and -2. So the new one is 0 0 1 1 -2. So we get our conclusion here. Then we need to find m31, and according to our echelon form here, row 3 column 1, this one we want to change it to 0. So a31 divided by a11, a31 31 11, so divide by 11, it will become -2 because we have negative here. So you want to change this row 2, -2 r1. This is row 3, this is our -2, this is our r1. But we can see here, when you do this, the r3, all of it will be 0. So this row all become 0 when you do this equation for r3. Alright? When we have this situation, we let the non-leading variables as parameters. Okay, so non-leading variables, this is leading variables, the x1, and then we go down, this is the leading variables, the x3. So assign the non-leading variables as parameters. So the non-leading variables here is x2, we assign it as s, and x4 we assign it as t. And then we solve leading variable using back substitutions. So x3, which is this one is equals to this one going back. So -2 minus t. Why t? Because t is substitute for x4. And then the x1, all of this move here. So 10 minus 2, s is our x2. This is our x2. 2s minus 3, x3 is this one. So x2 negative 2, negative 2, negative t, minus 4, which is a t, equals to 16 minus 2s and t as a solution. Gauss-Jordan elimination. In Gauss-Jordan elimination, elements above the diagonals are eliminated in the same manner as the elements below. So it is a reduced echelon form, means that 1 1 1 0 0 for both sides. Okay, we need to change from this metric first to where the reduced echelon form, the row echelon form, sorry, and then from the row echelon form we change to the reduced echelon form. After we get the reduced echelon form, then we convert back to the matrix, okay, and we calculate the value of the variables, the x. This is the calculation. If for E1 here we have D11 x1, E2 D22 x2, and the E3 D33 x3. So to find x1, 2 and 3, we will divide these two together to get the answer. Now the example, solve the system of linear equation using Gauss-Jordan elimination. They give us one system here. As usual, first we need to change it to the augmented matrix. Okay, then we begin our row operations. Right, first one is we exchange row 1 with row 3. So here and row 3 will come here. So we will have 1 as a starting point. Then we need to make sure that according to our reduced row echelon forms, this one is 0. Okay, so how to do that? M21 1 1 1 2, sorry, 1 1, it should be 2 1 3 1. So for 2 1 here, we must multiply by negative 3 like usual. So 2 1 1 1 divided by 3 divided by 1, we get negative 3. This is for 2 1. The 3 1 8 3 1, 2 divided by 1, so we will get negative 2. So the new R2 and R3, this one is for R2 negative 3, and then R1. So you will get the new R2, which is 0, 14, 7 and 7. This is the new R3, where R3 plus negative 2, this one is R1. So you will get the new R3. 0, 0, 14, 7, 7. So 0, 14, negative 7, 7, 0, 9, 3, 9. So the new R3, 0, 9, negative 3, 9. And we have 0 for the first column. Then we want to make this one become 1, right? So what we need to do is we change R2 with 1 over 14 multiplied by R2, so we get 1 in the middle. Alright, so this one become negative half and this one is half. Then we want to make these two columns 0, because according to our reduced echelon form, 1 1 1 0 0 0. We already finished with this, so this to the next. Okay, so in order to do that, we need to change row 1 and row 3. So row 1 and row 3, the new one should have 0 in column 2. So how to do this? For M12, M12, M22, M23, A12 divided by A22, negative 4 divided by 1. So we get 4. For M32, no, this is 3, sorry. This one's supposed to be 32. M32. So for M32, A32 divided by negative 1, A22. So we get negative 9. Alright. So this one should be 4. This one should be negative 9. And we multiply by the row. So this is for row 1, 4, and row 2. And the answer will be a new row 1. This one is row 3, negative 9. This one is row 2. And the answer to this will change row 3. Alright, then we can see that 1 0 0 1 for row 1, so 1 0 0 1 for row 1, and then 0 0 3 over 2 9 over 2 for row 3, 0 0 3 over 2 9 over 2 for row 3. So we have not just 2, 3 now is already 0, so we only have 2 to change now, which is these two. Then we focus on changing this one into 1. Alright, how to do this? We need to change row 3 because this is on row 3 by multiplying with 2 over 3. Then the result will be 1 and 3 for the constant here. So we have 0 0 1 3. Okay, we're almost there. Now for the last part, we need to change this one into 0 to make it in a reduced row echelon form format. Okay, this is M23. So M23 1 3, this is 3 3. A23 divided by A33, A23 divided by A33. So we got half. This half multiplied by R3 plus R2 will change R2 because we are in R2 here, right? So R2 plus half R3. So you will change the new R2. You can see here 0 1 0 2 is the output, 0 1 0 2. So we get our reduced row echelon form format here. Now, as you can see, this one is x1, this one is x2, this one is x3. So we convert it, x1 is equal to 1, x2 here is equal to 2, x3 here is equal to 3. So we don't need to do any back substitution. We already got the answer. Right, we have another example. This one is x4 until x4. Solve the system linear equation using Gauss-Jordan elimination. The first thing we need to do is change to augmented matrix. Okay, now we need to change this to 0. So we need to change row 2 and row 3. This is 1 1, this is 2 1, this is 3 1. So for M21 we need to multiply by -1. For M31 is -2. So row 2, the new one, will have -1 as their M21, -2 as their M31, to change these two to 0. So when we do that, this is R2, this is -1, this is R1. So this is the new R2. So this will be the new R2. This one is for R3, so we have R3, -2, R1. So this will be our new R3. As you can see, for row 2, 0, 0, 1, 1, -2 is the answer. And for row 3, everything has become 0. So, and then we need to change M13. So this one is M13. This is 2, 3. This is 3, 3. So, how to change this one to become 0? So we need to multiply by -3 and change R1. So the new R1 will be R1 plus -3 R2. So this is our R1, -3 R2, and it will become the new R1. So the new R1 will be 1, 2, 0, 1, and 16. Alright, then the last step here is to give the non-leading variables a constant here. Let's say this one is the leading variables, x1, x3 is the leading variables, but we have x2 here and x4, which is not a leading variables. Okay, for x2 is equal to s. For x4 we give it equal to t. Now x3 here is equals to t1. Yeah, x4 is t. Move it here. We move it to here. So -2 minus t, which is the x4. For x1, to move here, we move here. So x1 equals to 16 minus 2s, because s is x2 minus t, and this is x4. So this is the equation for x1, this is the equation for x3. This is another example. So in this example, we see they use R3 minus 4R2 to change R3 because they want to make this row 0. Okay, so by doing that, this column, row 3, column 2 here become 0. Then they want to change this become 0, and the way they want to do it by finding the M12 and changing the row 1. So here they already got row 1 plus the M12 here that they found is 2. R2 equals to R1. So they change R1 based from this equation. So R1, 1, -2, 4, 2, and then this is the M12, and this is the R2, 0, 1, 5, -1. And the results, they change R1, which is the new R1 is 1, 0, 14, -4. So let's see the R1 here. The new R1 is 1, 0, 14, -4. Then they want to change the column 3 here to become 0. So how they want to do it? They will they will find M13 to be multiplied by R3 plus row 1. They do this to change R1. Okay, this is because this is in row 1. So the M13 that they found is 14 over 31. And then they do the equation for R1 plus 14 divided by 31 towards R3. And they will get the new R1, which is 10058 over 31. Okay, this is the new one, 10058 over 31. Now they need to solve this to become 0. And how they want to do it? M23 because row 2 column 3, and then they need to change row 2. Alright, so negative 5 here. So this is the R2, 0, 1, 5, negative 1. Negative 5 as M23 multiplied by R3, 0, 0, 1, 13 divided by negative 31 here. So the new R2 will be 0, 1, 0, 34 over 31. This is the new R2. Alright, so based from this augmented matrix, we can see that this is equals to x1, this is equals to x2, this is equals to x3, and then you can do it in this format. T means transpose, 58 is the first one, and then 34 second one, and negative 13, 31 is the third one. X equals to these matrices. Although these two techniques appear similar, but of course, if you can see by the work that you need to do, the former, the Gauss-Jordan here, requires more work because it is in a reduced row echelon forms. Gauss-Jordan involves approximately 50% more operation than Gauss elimination. Therefore, Gauss elimination is the simple elimination method of preference for obtaining solution of linear equations. Now we come to metric factorization. Okay, the solution of system of linear equations ax equals to b that we have done before can be computed much more quickly if matrix A can be factored in the form of ALU. A equals to LU, which is L for lower triangular matrix, U is an upper triangular matrix. Before this, we know this form AX equals to B, where A variables and B. Then for metric factorizations, we have A equals to LU, which is this is the A, and we divide it into 2, which is the lower triangular L, and upper triangular, which is U. Now, how to calculate the lower and upper to become A? So, for A11 here, you need to have L11, U11. You need to multiply them to get A11. For A21, you need to multiply L21, U11, A31, L31, U11. Alright, for the second column, for A12, you need to multiply L11 with U11. And for A22, alright, you need to have two things. L21, and you need to divide by U12. So L21, you need to multiply by U12. Alright, and then you need to do another operation, which is plus the L22 and U22. Alright, you need to have two things, same as the third row here, second column, whereby you need to multiply L31 with U12 and plus L32 with U22. So you will get the A32 here. Now for A13, L11 and U13, so L11, U13, you will get these coordinates, A13, and then for A23, same thing as before, you need to have two operations, L21 multiplied by U13, and then L22 multiplied by U23, and you need to plus them up to get the A23. And then for the last one, you need to do three operations, multiply and 2 times of plus. For the first one, L31 U13, and then L32 U23, L33 U33, and then you need to plus them all to get the A33. Ax equal to b can be solved in two stages. The first one is solve Ly equals to b, y for forward substitution, and then solve ux equals to y for x by back substitution. We will see in the next example. For the forward substitution, Ly equals to b, alright, this is the equation. So you can see we change y1 equals to b1 here, b1 divided by L11. So we get our y1. For y2, our b2 here minus L21 y1, L21 y1, and then we divide by L22. For y3, b3 here minus L31 y1 minus L32 y2, and then we divide by L33. So we get our forward substitution. For our back substitution, ux equals to y, this is the equation. So we change first from the x3. So x3 equals to y3 divided by u33. For x2, y2 minus u22 minus u23 x3, and then we divide by u22. For x1, y1 minus u12 x2 minus u13 x3, and then we divide by u11, and then we get our back substitution. So we start with Doolittle factorization. The diagonal elements of matrix L are 1s. So this is the diagonal is 1, and we have A equals to LU, where A here is the same, the lower triangular, and then multiply by the upper triangular. Alright, this is the lower triangular. When you multiply by the upper triangular, okay, and then you will get your answer for the A's. This is the first example. Find the LU factorization of matrix using Doolittle form and use it to solve the linear system. They give us this linear system, and they want us to find the factorization using Doolittle form. Okay, first step is to look back at the matrix factorizations, the equation before, to solve this type of problems. Okay, first one is I give you the overview here: L11, U11, L21, U11, L31, U11, and then L11, U12, L21, U12 plus L22, U22 plus L31, U12 plus L32, U22. The third one is L11, U13, and so on. And then this one is equal to A11, A12, A12, A13, A21, and so on. Alright. How to find U11 here? So basically you see U11. So U11 is equals to A11 divided by L11. So A11 is 1 divided by L11 is 1. So the answer is 1. For U12 is equals to, if you see U12 here, this here, right? So this is the equation. So 2 is A12 divided by L11. So the answer is 2 divided by 1. For U13, this is the equation. So we will have equals to A13, which is this one, divided by L11. L11 is still 1 here. L11, so 1 divided by 1. So you get this answer. Now I want to find L21 and L31. For L21, the equation will be A21, which is this one, right, divided by, look back to the equation please. Alright, A21 divided by U11. So you will have L21. So U11 is here. So 3 divided by 1. So you get 3. For L31, you need to have L31 here. You want to divide by A31 divide by U11. So the answer is A31 is 1. U11 is also 1 here. U11. So this one divided by this one, you will get 1 as the answer. So for this step, we need to find U22 and U23. So the U22, if you look back to the equation, of course it will be here, A22. Now we need to minus because we have two equations there. Look back to the metric factorization equation. For U22, we will need to minus L21 multiply to U12 and then we need to divide by L22. So what is A22? A22 is here 1, and then minus L21 is 3 multiplied by U12 is 2 divided by L22. L22 is 1. That's why we don't have here, especially 1 here, so it will be negative 5. For U23 is equals to A23 minus L21 multiplied by U13 divided by L22. So we get the answer. This is A23. Okay, for L21, got 3. This is L21. So we got 3 multiplied by U13. U row 1 column 3, this one, U13, and then we need to divide by L22. L22 is 1, and then you get your answer -2 for U23. So we need to change -5 and -2. Next, we need to find L32. So for L32, the formula should be L32. Look at the metric factorization formula. L32 is equals to A32, which is A32 so A32 will be minus L31 U12 L31 U12 divide by U22 U22. So this is A32, sorry, this is A32, and then L31 is here, L31 1, U12 is here, U row 1 column 2 here, and then divide by U22 -5. So this is your L32. The last part we need to find is U33. So for U33, the equation will be A33 minus L31 multiplied by U13 minus L32 multiplied by U23, and then we need to divide this by L33. So A33 is 2, L31 is 1, U13 is 1, and then L32 2 over 5, and then U23 -2 divide by L33, which is 1. Okay, so divide by 1 is equal to 1 over 5 for U33. So we change the L33 to 1 over 5. U33 to 1 over 5. Okay, now we look back to the questions where we will get the 8, 11 and 14. Alright, for y1 is equal to 8, this is 1, y1 is equals to 8. For y2, we got 11 here minus 3 over 8, because we have y1 is 8, right? So this one is y1, 3 over 8, and we got -13. So basically this is over 8, this is over -13, and then if you move all over here, we have y3 is 4 over 5, and then we'll see the u, x, and the answer that we get before. If we change it to the form of x3, x2 and x1, for x3 here it is 1 over 5, we need to move it here, so 4 over 5 over 1 over 5, we get 4. So x3 here is 4. x2 -13, and then we need to move the x3 over here. This is the -2 x3, and we divide by, this is x2, right? This is x2 here, we divide it to negative 5. So we get your answer x2 equals to 1. And then we insert here, so this is 1, so this is 4. So move all over here, and 8 minus 2 multiplied by 1 minus 1, 4, and divide by 1. So you will get your answer 2. Now we will see the Crout factorization where the diagonal elements of matrix U are 1. So the first example, find the LU factorization of the matrix using Crout form and use it to solve the linear system. Okay, they give us this linear system. So now for Crout, you see the U is 1. For Doolittle before this, the L is 1. Then we need to make this form. LU is equals to A, LU equals to A before we solve this equation. Same as before, we look back at the metric factorization equation, and in order to find L11, if you see the equation, we need to A11 divided by U11. So A11 here is 7, right? 7, and U11 is 1. So we get 7. And do it for the same thing for L21 and L31. Find the metric factorization equation, and then you will get your answer. Now for U12, if you look at the metric factorization equation, U12 is equals to, U12 is here, by the way, here, U12, need to find that. So A12 divided by L11. So the U12, the A12 here, sorry, is 2. L11 here is 7. So that's where you get this answer. Do the same for U13. Go back to the metric factorization equation and find the equation like this, and then you can get your answer for U13. Now they want to find L22. So if you look back to the equation, in order to find L22, you must have A22 minus L21 multiplied by U12, and you need to divide by U22. So A22 is 5 minus L21 2 multiplied by U12 2 over 7, and then we need to divide by U22 which is 1. So you will get this answer. Okay, for U23 which is this one, U22 and U23, L22, and then we need to find U23. The equation, if you look at the metric factorization equation, will be A23 minus L21 U13, L21 U13, and then you need to divide it by L22. So if you do the calculations, A23 is negative 3, and then we need to minus L21, L21 here is 2, right? L21 is 2 multiplied by U13, U13 3 over 7, 3 over 7, and we need to divide by L22. L22 we just calculate before is this one, 31 over 7. And then you will get this answer for U23. Then we need to solve L32 and L33. And then I suggest you look back at the metric factorizations, find the equation how L32 you need to find, and find the equation for L33 how you can find it. Then you will get your answer for both. Then you change the L32 and L33 respectively, and then you will get these equations. Okay, then when you substitute the question, where you get this, alright, substitute the question, then you can find y1 here is negative 12 over 7, because this is y1, right? So we change here and we divide by 7. For y2, this is y1 here, we already got the answer, negative 12 over 7. Y2 is 31 over 7. So if you change all of it here, you will get this as answer. And we can say that this is negative 12 over 7. And we also have y2, which is negative 116 over 31, which if you let both to the other side, you will get y3 equals to 902 over 192. Then the answer from the previous y, we need to find the x, right? For x3, this one 1 over x3, so 1 over here divide by 1, so it's still 902, 192. And then you already got y3, so it's supposed to be here x3, so this is the equation, so you will get x2, so we already have x3, we already have x2, now we need to find x1, so you just put into the equation, you will get your x1.